Alright, in this lesson we're going to be moving the other direction. We're going to be taking a scientific notation and converting it to standard notation. So this one's more straightforward, I think. In other words, whenever the exponent's negative, you move to the left. Whenever the exponent's positive, you move to the right. So we're going to go ahead and take a look and see how to take a scientific number, convert it back to a standard or normal number. Alright, so let's take a look at some of these numbers that we've looked at. First of all, this is a scientific number. We're basically going to be taking something like this and writing it as a normal number, like for example 370 trillion or whatever. Okay, or let's say we have a negative exponent. It will become a decimal. Let's basically take a number like this, move it back to decimal form. That's what we're going to be doing in this lesson. Let's go ahead and take a look at example 1. So we have 1.73 times 10 to the negative 4. So the question is, what do we do? Alright, well, let's go ahead and take a look at the steps. Like I said, for this lesson, when going from scientific back to standard, the exponent will determine which direction to move. If it's negative, you'll go left. If it's positive, you'll move the decimal to the right. So that leads us to the first step. Move the decimal based on the exponent, okay? If the decimal's negative, move it left. If the exponent's negative, move the decimal left. And if the exponent's positive, move it to the right. Pretty simple. Let's take a look and see how that takes shape. So normally what I do is I just rewrite my number. So we have 1.73. Okay. I'm going to just take a look at this exponent. Okay, it's negative 4. Alright, so let's go ahead and start to move that decimal. And I'm going to move it 1 to the left. Now here's the issue. Once I move it 1 to the left, there's no more digits there. Okay, so we can see there's basically nothing here. So this leads us to step 2. My students have done a great job at executing this. Insert zeros where needed. Okay, so anytime there's not a zero anytime there's not a digit there, you want to keep inserting zeros so that you can move that decimal over. And that's also true when you're moving the decimal to the right and you run out of digits. Just take a look. Alright, so after I've moved this 1 to the left and there's no more digits there, I'm simply just going to put a 0 there. Okay? So I've moved it 1 to the left so far, okay, but when I move it again, okay, we're good, right? But we have to move it 2 more times, so I need to put another 0 there. Okay? And again, I'm going to move it a 3rd time. It will go right there. However, I need to move it 1 more time to the left. Now in this case, I don't need to put another 0 because we've already moved it 4 units left. So we go 1, 2, 3, 4, and that's where our decimal will go. Some people might put a 0 to the left of that, but you only need 3 zeros here because this first time we had a 1 here. So make sure you insert zeros whenever you're moving a decimal and you run out of digits. Okay? Final step, simplify. Okay, so what I can simply do, I'm actually basically done with this example, but what I can do is just rewrite it. So my final answer is 0.0000173. Okay? And that's what happens when you start with 1.73 times 10 to the negative 4, and you move that decimal 4 units to the left, making sure to insert these 3 zeros. Alright, that's it for this example. If you have any other questions about it or converting back to standard notation, let me know.